All right, so let's take a look at the scientific method. You know, there isn't like a one method fits all. But in general, actually everyone I knew working in science followed this procedure. And that is, in the scientific method, there's certain steps. The first one is just observations. What do scientists do? What do chemists do? Well, scientists observe nature. They try to figure out, well, how does nature work? How does matter interact? That's what chemists would do. They would look at matter. What are the interactions of matter? In fact, what is the definition of chemistry? Do you guys know what the definition of chemistry is? How would you have defined chemistry in Chem4 or Intro Chem? What would it doesn't have to be perfect. Just any definition is fine. What was your definition? Or anybody?
Just like the study of nature, of interaction, and matter.
Yeah, study of nature, interaction, and matter. Exactly, interaction of matter. And so, chemists, they study the interactions of matter. In fact, the interactions would be properties of matter. In other words, what do chemists do? They study the properties of matter. What are the properties of matter? There are physical properties. You guys remember, what's the definition of physical properties? Maybe long summer or sure. Yeah, physical properties. You want to go back. There's a lot of review, but it's just going back and just refreshing your memory about what physical properties are and what chemical properties are, because chemists are going to study the physical and chemical properties of matter. And what is matter? Anything that has mass and takes up space, so everything. And so chemists study basically everything, the physical properties and the chemical properties. But oftentimes we don't talk in terms of matter, right? We'll talk about substances versus what? Substances versus, if you have a substance, you want to make sure, oh, I have this liquid in here. This clear, colorless liquid. Is this liquid a substance or is it a mixture? So we got substances and mixtures. And how do you define a substance? Or one kind of particle, yeah. And those particles could be molecules or atoms. That's good. We wouldn't call them particles necessarily, but a substance is just made of one type of atom, or whoops, I hope this wasn't too toxic. But this is probably water, right? How do you know if this water is pure or mixture? Is this a mixture or is this pure? It's pure. How do you know it's pure? It looks pure? If it looks pure, then yeah, because pure substances should be homogeneous, right, versus heterogeneous. And so it's homogeneous. Since it's homogeneous, does that mean it must be pure? No. Is it possible to have a homogeneous mixture? Sure. So this could be a homogeneous mixture. So now you tell me, how can I tell if this is homogeneous pure substance or homogeneous mixture? I'm sorry? Yeah, right, exactly, by its properties. We know that substances have a fixed set or a variable set of properties. A fixed set of properties. So we measure the properties of this. What types of measurements, what types of properties would you measure? Well, when we're typically doing measurements, we look at intrinsic properties and extrinsic. What's the difference between an intrinsic and extrinsic property? like for example, extrinsic property would be like its mass. Would the mass of this help us very much in identifying? I got about 30, maybe 40 grams. Is that going to help us identifying this? It's an extrinsic property. Extrinsic property versus intrinsic property. Intrinsic property would be like density. Would density help us in identifying this? You know, if the density of this were 0.6 grams per milliliter, would you say this is pure water? 0.6 grams per milliliter. Water? No, it's more likely alcohol. Alcohol has a much lower density usually than water. Right? So we could use density. Density is intrinsic property. So what's the difference between an intrinsic and extrinsic property? Extrinsic properties depend on the amount. Intrinsic properties are independent of the amount. So give me some other intrinsic properties that you might think of. Boiling point. Does the boiling point of water depend if you have a gallon or 10 gallons? Is 10 gallons of water, does that have a higher boiling point than 1 gallon of water?
Yeah.
No, so that's intrinsic, right? It's independent of the amount. Right? That's another good thing to try, because if the boiling point of this were 80 degrees C, would you say it's pure water? No. And so the way we identify is this pure or not is by measuring its properties. We observe its properties, right? Observe is just measure, take measurements. Its properties. How many properties would you like to observe before you drink this, saying it's pure? You know, what is enough? If you just look at the color and say it's clear, is that enough? No, obviously not. I mean, how many? If you measured its density, would that be enough? No, because there could be trace amounts of impurities, and those trace amounts of impurities, would that change its density by much? Probably not. And so, you know, before drinking this water, you'd probably want to take lots of measurements to make sure that it matches all the physical and chemical properties of pure water. You probably can't match all of them because, you know, there are a lot of properties, right? A lot of chemical properties, a lot of physical properties. In order to do that, but you know, that's our start. Nowadays we have instruments. You know, like I was saying earlier about the geology, the mineral. You know, what mineral is it? Well, we got a lot of instruments that can detect trace amounts of impurities in waters, and you can do that. Or the easiest thing, you know what most people do? They just filter it. They'll filter it using maybe some reverse osmosis system, get rid of the impurities, and then drink it. Maybe add some minerals to it. It also depends on the source. And so, you know, we're dealing with substances and mixtures. With mixtures, you know, this could be a mixture, and this mixture, let's say this was 20% alcohol, 80% water, that would have a fixed set of properties as well. But the thing about mixtures is you can vary the amount of alcohol, which varies things like its density, which varies its boiling point. It's like sugar water. You know, is there a fixed sweetness to sugar water? Is all sugar water the same taste? No, it has different taste because it has variable composition. Variable composition means variable properties. And so what you should do is, you know, if these terms are a little fuzzy, you should go back and review all those. Take a look in the glossary and stuff.